geometry. Descriptive geometry is a subject describing the geometric shape and dimensions in space in terms of starting points, lines, and surfaces. And you may probably have recognized the difficulties involved in it. The ideas involved in it, or concepts involved in it, are rather abstractive. So in order to help you, I have summarized some of the important fundamental concepts and put them in online, your courses. So those are the summarizations, I think, very important. So how do we use that? That is what I would like to briefly discuss today. Let's say I have a line, okay? A line in space. Then we usually use a front view or elevation view, horizontal view, and any other views that we may probably associate with our understanding of the geometric location, dimension, shapes, etc. The information. So that requires us to have a very clear idea about the space. We can only draw those lines and planes, points on the piece of paper, which is 2D. So together we have top view, elevation view, and front view, etc. Once we have those views, we may have to have some kind of capability to interpret them in a three-dimensional manner, which is in our mind. That is something in space. For example, that line. Okay, let's have a look at the concepts that I put in there. Descriptive geometry concepts. Larger. Okay, so now let's have a look. How do we use those concepts that I have described in the last week's lectures? True length of a line, for example. True length of a line can be viewed. You can do the measurement in the view, which is parallel to the line. That is the key. Let's say we have a line in space, line 5, 6, in the front view, and we see something like that, with the length and orientation. In the top view, we have the length and orientation differently. However, it should obey the principle of projection. Principle of projection means that you have a projection line here that is perpendicular, and correspondingly 6, 6, 5, 5 should be drawn in a way that obeys the principle of projection. Another thing is that you see this folding line. This folding line. The folding line there means that we have two planes perpendicular to each other. Easy to say, but hard to understand. Let's say I just copy it there. And that's my line. My line. And I have a, let's say I have a darker pen here. That is folding line. Okay. Here we have front view, top view. What I meant here is that's how we see it. Right? Front view and top view. But to an engineer, you cannot just get in hiding here inside and do the measurement, right? You can only do this. So although we have a folding line there, that folding line should be interpreted as the intersection line of two planes perpendicular to each other. That's how we do it. Good. If that is understandable, and in the last class, we have said, in order to find out the true length, then we have to generate a view. We have to generate a view parallel to my line. That means I am generating another plane which is perpendicular to the horizontal plane. And that means I am generating an elevation in which I can measure the elevation. Again, easy to say, hard to see, hard to understand. Okay, so what we did was, see 5, 5, this is a 5, and this is 6, and we do the measurement. This distance is this distance. This distance is that distance. And then connect those two points. You got the true length. So, let's just use this piece of paper again. Same thing. And we say, oh, okay, you said you generated another line. Let me just draw it by freehand, okay? This is another folding line. And I have a line true length 5, 6 true length. Very good. Okay. So what I have done, you see this is front view, top view. I fold it, right? Then I generate another plane by draw a folding line. That means I have another plane which is perpendicular to the horizontal plane. Then I fold it again. And in which, because I am drawing the line parallel to it, then actually I am doing something like this. You see here? Front view, horizontal view. This is elevation view, and this is another elevation view. This is a horizontal plane. So, since I am copying the horizontal plane by a vertical plane, which is perpendicular to the horizontal plane, and parallel to the line that I am considering, therefore, in that view, in this elevation view, I see the true length. You see here, horizontal plane. Horizontal plane. Cut it here, cut it there. Then, of course, in this new vertical plane or elevation view, I can see the elevation here and here. Doesn't matter, right? Wherever I cut it. So long as I have a plane perpendicular to the horizontal plane, then I can do the element. I can do the measurement for the elevation. That is what we should understand. So then if we open it up, we have those three views. They are all in the piece of paper, which is two-dimensional. I really hope that you will go home and do some of the exercise like this and use a piece of paper and draw them. And if you really have difficulties to understand a line in the three-dimensional space, and how do we associate this line with all those planes represented by the 14 lines, then you better do this. Okay? You can do the 14 of the papers at home. So let's have a look of what I have written there. You see, if you have a cell phone or anything like that, you install that into your computer or your cell phone and say that, well, what is the true length? True length can only be viewed, can only be seen in the view which is parallel to the line. That should be understood. Or should be understood in that way. Okay? And then what do you need? In order to find out the true length of the line, then you need a view parallel to the line. Definitely. And another view, a neighboring view, perpendicular to view A. That's view A is what? View A is the true length view. The true length view. Then you can measure the elevation. Okay? So if you have a view perpendicular to the true length view, which is exactly what we have done, and we have this view, elevation view here, and that elevation view there, as I said in the last week. And you have two views. This front view and that view, the third view. They both share the horizontal view. Therefore, those two views are all elevation views in which we can measure the elevation. We can measure the elevation. Okay, and I don't think that it is that difficult if we do some exercise at home. Of course, this is something new. I know that. I know it is difficult always, every year, the same thing. Yes, come here. It's too far from me.
Sorry, this is one question.
As I said, you're too far from me.
Last line, the first line. Are they parallel or not?
Parallel.
Yeah.
Those two lines, the black lines, the two black lines, they're not parallel to each other.
The first and the last one.
The green one, the green line is parallel to 5, 6 there. That's the top view. That is our top horizontal. Okay? That green line means that we are generating a vertical plane or elevation view. The reason that we do the parallel plane is that we want to see the true length. And in order to find the true length, you need to know the elevation. Once you have the shape of the line and you have the elevation, then you can completely describe this line. Okay, then? Hopefully that will help you to understand it better. And I have all of those. Anytime that you need to do true length or whatever we have discussed, see those slope and point of view, etc. When you get to the time to do that in the exercise or in the lab, review those. It may help you. Okay? And if you still have some difficulties, then you see I have asked Trevor to help us to record all the lectures, well, at least lectures for the descriptive geometry. Review those at home or any time that you have a spare time. Not using a computer or using a cell phone, wherever you get to the point that you have difficulties. Okay? As I said, this section is difficult. It is. Every year, same thing. So you have to spend time, and spend time on what? Lecturing. Do not miss any lecture. And do the exercise. And if necessary or if needed, we may have to do more exercise at home. Yes?
We'll do tutorials on Tuesdays and Thursdays.
Exactly. So that's what I'm going to say. Tuesdays and Thursdays, we have the tutors there to help you. Go there. Search for help. And I should be in my office most of the time. And if you need help, face-to-face, come to my office. Okay? And of course, tutorial section, we paid these guys to help you. And then take the advantage. Okay then? As I said, this part is difficult, abstractive. I know that. Every year, same thing. So it combines all the knowledge that we have discussed previously, especially the principles of projection. Another thing that I should mention is you will have those kind of questions in the final, for sure. Okay, we cannot avoid that. And if you are in petroleum engineering or civil engineering, especially, then you must understand this. As I said, for the survey that people are doing, the engineers are doing to search for mine and for pipelines and for water, for coal, then you got to understand this. Okay? Then that's your job. So this part is necessary. Okay then, I think I have emphasized the importance enough, so spend enough time. Okay, let's continue what we have discussed in the last week lectures. We have discussed about bearing and slope. Bearing, slope, is there, I don't want to repeat. Bearing can only be measured in horizontal plane. That is a must. You must understand that. Slope can only be measured in the elevation, perpendicular to horizontal plane. And you need a horizontal plane to do the measurement. Okay. So, once we understand that, let's say this is a front view. Okay? This is a front view. This is a top view, or horizontal view. If that's so, as we said, then actually you're saying something like that. Front view, top view, and open it up. Then, if I have something here, this is the front view, then this distance is considered as behind, right? Something behind the front view. If you have something here, then this is a horizontal plane, then you will say below, this line is below the horizontal plane. That's how we do the description. If that is understandable, then let's say this description here. Draw a true length. Find out the true length view of line AB. We don't know where is AB yet. Okay? By projecting from the plan view. What is plan view? Plan view is what view? Horizontal view. Okay? Plan view is the horizontal view. And from the front view, that's the problem. And everything is 1 to 1. A is 14 millimeters behind the front plane and 8 millimeters below the horizontal plane. So below and behind should be interpreted in the way that I have just described. So let's say if you say, well, I have a front view and horizontal view, I can write that way. Then right away you understand I have two views perpendicular to each other. Although I'm just using a line, 40 line, to represent the intersection. But you should understand that on the top view or horizontal view, bottom is front. So that's how we do it. Right? Then once I have a line, everything is clear. I have two planes perpendicular to each other. One is horizontal, another is elevation or front. If that's so, let's say I have A here. A is 14 millimeters behind. Behind means that from here to here, let's say I have this distance. $14 millimeters. And also, there is 8 millimeters below. So by the principle of projection, I know this point here. The point must along this line, and that is 8 millimeters. So this is point A. This is point A. Point A, sorry. Point A. And that distance below means this distance is 8. Let's have a look at the B. B is 22 millimeters behind. Now we know how to do it. Behind the frontal plane and 20 millimeters below the horizontal plane. Let's put another thing here. And 30 millimeters east, let's say, left point A. East, horizontal. So, once again, if we talk about bearing, if we talk about the north, the south, west, east, you must associate your measurement with the horizontal plane. Must. Okay. If that's so, then we will say 30 millimeters east. 30 millimeters east. Let's say 30 millimeters. This is 30 millimeters east. And I know that B is 22 millimeters behind. So behind, then I have actual B point should be somewhere here. This is my B point. And this distance behind, that is 22 millimeters. 30 millimeters east of A, point A. And 22 millimeters behind the front view. Okay, another one is 20 millimeters below. 20 millimeters below. Then I can say, oh, by the principle of projection, then I have somewhere here, let's say, then I done. I don't have time to do it that accurately, but something like that. Then you know your line. A, B in the front view and in the horizontal view. From the two views, you can easily find out the true length. How do we do the true length? Let me do it again. and you draw a line parallel to this. You generate another folding line and and you have this distance 8 somewhere there, and this distance 20 somewhere there, and draw a line to the zone. That's how we do it. And in which you can do the measurement for this flow. Okay, I don't think I need to talk too much about that because I have more to describe. Another thing is the shortest distance between a point and a line. Shortest distance between a point, let's say I have line 1, 2, and the point O. Let me write it here. Line 1, 2, and a point is O. I want to find out the shortest distance between point O and the line 1, 2. First thing that we have to understand is that let me do it again. The first thing is that in the true length view of the line, the line connecting point O and the line 1, 2 line is perpendicular to the line. What is the line? The line 1, 2. So we have a connecting line between the point and the line, and we have a line 1, 2. Second thing is, in the point of view of the line, what line? The line 1, 2. The true length of the connecting line can be shown. That is the 2 points. We are saying, what do you mean by the shortest distance between a point and a line? Then we are saying the connecting line must be perpendicular to the line. That is the shortest distance by the fundamental geometry that we have learned in high school. That is our conclusion. Very true. It is true. So those 2 points are actually our base for developing a technique in order to find out this shortest distance. What do we mean by shortest distance? Shortest distance is the true length, the connecting line, which in the true length view of the line 1, 2 shows the connecting line is perpendicular to the line. Okay, let's see we do it. I don't know if I can do this or not. Okay, so now we need to find out a true length view for 1, 2. Okay, if that is the case, then we draw a line, folding line. Parallel to it, this is folding line, okay? And we can find out this becomes an elevation view because this view and that view sharing this view. And 2. Then I have tulip generated. As I said, we need to write tulip 1, 2. And here, principle of projection, I know this O, elevation of O, on O here. So I must have a point there. That's my O. And this O should, now I have true length, should be perpendicular to my true length view. That is our conclusion, which is based on the geometry. Okay, shorter the distance means that from point to the line, that connecting line is perpendicular to it. Once that is done, point view of this line, point view, and this new folding line is perpendicular to this, perpendicular to it, and in which I can find out the distance of the line. And this is my point 1, 2. 1 and 2. And where is my O? My O is there. Perpendicular to or parallel to this line, same thing. The folding line. And O, the elevation. That gives me the connecting line, let's call it true length 2. This is true length 1. Done. Wow, I know. You see, one folding line dividing top view or horizontal view and front view, easy. Another view, another folding line would be difficult. Now we have 3 folding lines. Then you have to really think about it. Nothing is really new. We have talked about those point of view, how to draw the point of view, how to draw the horizontal, the true length view, etc. Okay? When you get used to it, once you draw a line representing the folding line, then right away you have an idea. The 2 planes perpendicular to each other. Another thing is that if I have 2 planes sharing the same plane, then the information, the elevation information in the two views are the same. That is the key. Okay? And I know there are some students going to do the labs. There are two things I have to probably add in. Shorten the distance. You find the true length and the true length of the connecting line, and you find the view, which is a true length view for line 1, 2, and in which the connecting line is perpendicular to the line. Okay, attribute. Attribute EV. I have it shortened distance. I have it there, and you may go home and review them and do some exercise, and also attribute and true shape view. Attribute. You see, attribute means a view in which we see the plane, let's say this triangle is a plane, as an edge. How do you do that? In order to do that, then if I say I see this, the line, a line, in the plane, let's say this edge. If I see this edge as a point, then doesn't matter how I rotate it. I see this plane as an edge. That is the key. So, in order to generate an attribute for a plane, we need to find a line in the plane and view it as a point. Then we have the attribute. Okay, this one is relatively simpler because you see, I am saying that line 7, 6 is parallel to the 40 line, this 40 line. Let's make things simple. If that's so, then I can find out A line. The A line is 7, 6 in the plane, and view it as a point. Then I would have if 7, 6 is parallel to this, that means in this view, I can see this line as a true length. Do you agree? If that's so, then I may extend it and draw a line. I need a triangle. But in practice, what you should do is, you have this and this line and that line, and then this must be perpendicular to it. Okay? So then I may see this line 7, 6 somewhere here as a point. Then that the elevation of this 7, 6, this view and that view share this view. Therefore, I can do the measurement here and say, well, that is 7, 6 point. If that's so, I may see, okay, well, by the principle of projection, I may see this 5 somewhere. And then my edge view is done. Once I see a line in the plane as a point, then in that view, the plane changes to be an edge. Another thing is that if we parallel to this one, parallel to this edge view, and I draw a line, then what? I have a plane that I can see as an edge. If I see it in this way, in order to do that, I have a plane, a view, parallel to this plane. Then I can see the full size, the actual size, or true size of the plane. Okay? So that means if I draw a folding line here, a view parallel to the edge view, then I can say the true size of the plane can be generated. So this view shared by this view and that view, therefore I measure it from here to here. 6. 6, 7, 7 there, that's 2, 4. And I have 5. Then I can have true size view. Of course, that's much larger than the other one. Well, let's read them through. What I have done are the procedures. Edge view. What is the edge view? A plane is shown as an edge only in the view which is perpendicular to a true length line, a line, okay, in the plane. So what do we need? Then perpendicular to the true length view would be point, right? So true length view, we have that. We have true length view. And then true length, the green one, you can see that. And then we need a view perpendicular to true length view. That is the top view that we have seen there for the measuring of the elevation. Okay? Another view is the top view. So we have a plane perpendicular to the true length, that will be point view. And elevation there would be the same. So then we can have that. Once we have the edge view, then the true shape can be found. Let's say, what is the true shape? True shape view. The true shape view, or true size, we should write it as TS. This is the true size view. Okay, so if a plane can be viewed only in a view which is parallel to the plane. That's exactly what we did. And edge view, we need an edge view. We started with the edge view. Edge view there, parallel to it. And the true size view appears as a view parallel to the edge view. And then If we have this view and another view sharing the same view as the edge view, then we can do the elevation measurement. That will give you those. And this conclusion will be discussed later. Any view which is perpendicular to the true size view shows the edge view. Lovely. We will discuss that later. Okay, so take advantage of this and go through the lectures that I have done in last week, and you need more time for sure. Okay? The video and the tutorial section, take advantage. Okay? That's all for today. Thank you very much. This is the lady